In today's video, we are going to be talking about expressions. You guys should all be familiar with something that looks like this. This is called an expression. An expression is something where we have a sum on the one side with something missing over here, and we need to find that missing something. With equations, we no longer have a missing something over here. Instead, the something that we need to figure out is part of the sum. So for this equation, we would need to figure out what x is. And to do that, we would need to get rid of this 2. Now, another way of looking at this is just by simply saying x plus, or rather 2 plus what, gives us 5. So we know that 2 plus 3 is equal to 5. Another way of figuring that out would be to subtract 2 from 5, and that gives us that x equals 3. Equations are all about trying to figure out what our missing value is, what our x is. So in math, remember, we do not like to denote missing values with a question mark. Instead, we let them be denoted by a variable. In this case, the variable we chose was x. So we've got a missing value over there, and we need to figure out what that missing value is. And for this example in particular, we found that x equals 3. So we can substitute this value for x back into our equation. So instead of having x in our equation, we can write 3, and then we say plus 2 equals 5. And as we can see, this is true because 3 plus 2 does in fact equal 5. As we are always trying to find out what the missing value x is equal to, we are always trying to get x by itself. So we are always trying to get our equation to eventually be in the form of x equals something. And because of that, we are always trying to get x alone. As you'll see later, this is why we always make sure that we move our x's, our variables, to the left-hand side, and we move all of our constants to the right-hand side. For question 1, we have 6x plus 3 minus 7 equals x minus 6. What I like to do is to first move all of my constants to the right-hand side, and once that is done, we move our variables to the left-hand side. It does not matter which order you do this in. If you wish to, you can move your variables to the right-hand side first, or rather to the left-hand side first, and then move your constants across to the right-hand side. But for these examples, I'm going to be moving the constants to the right-hand side first, and then I'll be moving the variables to the left-hand side. With that in mind, let's have a look at our constant terms. So we have plus 3 as a constant, minus 7 is a constant, and minus 6. And we already see that minus 6 is already on the right-hand side. That means we just need to move the positive 3 and the negative 7. However, since we already have 2 constants on the same side, we can make things a little bit easier for ourselves by letting these 2 constants add. So we will get 6x. Now, positive 3 minus 7 gives us negative 4, and that equals x minus 6. And now it's a lot more straightforward to move this 4 across instead of individually moving the 3 and then moving the 7. So we know that we need to move this negative 4 to the other side. We know that we do not want it on our left-hand side. We only want we only want variables on this left-hand side. So, in order to remove negative 4 from our left-hand side, we simply will add 4 to the left-hand side. And this is because we know that negative 4 plus 4 simply gives us 0. And remember, whatever we do to the one side, we have to do to the other. So we will add 4 there as well. This then means that we will be left with 6x on our left-hand side. Negative 4 and positive 4 give us 0, so we can simply leave that out. And this equals x. Now once again, we have two constants over here. So we say minus 6 plus 4, and that'll give us negative 2. So our first step is now complete. We have successfully moved all of our constants from the left-hand side to the right-hand side. Next, we need to move all of our variable terms from the right-hand side to the left-hand side. So as we can see, 6x is a variable term and x is a variable term, right? But 6x is already on the left-hand side. So that means the only one we need to move is x. And to move it, we are going to get rid of it firstly on the right-hand side. To get rid of x on the right-hand side, we simply need to minus x, because remember, positive x and minus x gives us 0, just like we did with the minus 4 and the positive 4. Remember, we added 4 because we had negative 4 and we wanted 0. So because we minused x on the right-hand side, we need to minus x on the left-hand side as well. Okay, and once we have minused x from the right-hand side, we know that we are only going to be left with minus 2. And on the left-hand side, if we have 6x minus x, it's the same as saying, if I have 6 apples and I minus 1 apple, how many apples am I going to be left with? I'm going to be left with 5 apples. All right, so now we have got that 5x equals negative 2. Now remember what I said earlier. We want our equation to eventually be in the form x equals something. But if we have a look over here, we do not have x by itself. We have 5x. So what does that mean? We need to get rid of this 5 in front of the x. And what is that 5 called? That 5 is called the coefficient. So what we do is we divide this term by the coefficient, which is 5. Because remember, 5 divided by 5 is 1. And we just want 1x by itself. And whatever we do to the one side, we have to do to the other. So we divided on this side to get x alone, and we divided by 5. Therefore, we have to divide this side by 5 as well. When we divide 5x by 5, we will be left with just x, which is what we wanted. And on the right-hand side, we are left with this fraction, minus 2 over 5. And that is our final answer for question number 1. Question 2 gives us minus x plus 5 equals 2x plus 7. Right, so step 1, move all of our constants to the right-hand side. We have plus 5 and plus 7. These are our two constants. Plus 7 is already on the right-hand side, so we only need to move the 5 across. How do we do that? Well, we need to first get rid of the 5 on the left-hand side, and we do that by minusing 5. And whatever we do to the one side, we have to do to the other. So since we minus 5 on the left-hand side, we have to minus 5 from the right-hand side. So if we have minus x plus 5 minus 5 on the left hand side, the plus 5 and the minus 5 cancel, and we are just left with minus x on the left hand side. On the right hand side, we have 2x plus 7 minus 5. We all know that 7 minus 5 is 2, so we are left with a 2 there. And remember, it's positive 2 because it was positive 7 minus 5. So we got plus 2. Now we've moved all the constants over to the right-hand side. We now need to move all of our variables to the left-hand side. And as we can see, we need to move 2x over to the left-hand side. To do this, we are going to need to minus 2x from our right-hand side. And since we minus 2x on the right-hand side, we do the same thing to the left-hand side. And remember our reason for minusing 2x, we wanted to get rid of a positive 2x. These two will cancel to give us 2, and we will be left with just this 2 on the right-hand side. If we take a look at the left-hand side, we see that we have minus x minus 2. Because both of these terms have the same variables, we are able to let the coefficients add up. And if we say minus 1 minus 2, we can know that that is going to be minus 3. Therefore, minus x minus 2x is minus 3x. So we now have minus 3x equals 2. We are not done there because remember, we need x alone. We want x equals something. So to get x by itself, we are going to divide minus 3x by the coefficient of x. And the coefficient of x for this example is minus 3. Remember, the coefficient is simply just the number in front of x. So we divide by that number. And whatever we do to the one side, we have to do to the other. So we divide 2 by minus 3. We will then be left with x after we divided the minus 3 by minus 3. Remember, anything divided by itself is simply just 1. And there's an invisible 1 in front of that x there. And this equals minus, well, it doesn't actually matter where we put the minus, but it will be minus 2 over 3. And that is our final answer for question number 2. For question 3, we have minus 2x minus 3x equals 10. Step 1 would be to make sure that all of our constants are on the right-hand side. And as we can see, 10 is the only constant we have in this expression, and it is already on the right-hand side. Next, since we have finished step 1, we can move on to step 2. And step 2 is to move all of the variables to the left-hand side. And as we can see, minus 2x is a variable term, and minus 3x is also a variable term. And we can see that both of these terms are already on the left-hand side. So all that is left for us to do is to go minus 2x minus 3x. And as we know, minus 2 minus 3 is minus 5. Therefore, minus 2x minus 3x will give us minus 5x. And this equals 10. And once again, we want to make sure that x is alone because we are trying to find what x equals. We want the value of x. So to get x alone, we divide by his coefficient. And his coefficient, as we can see, is minus 5, which is why we divide by minus 5. And whatever we do to the one side, we once again do to the other. So we therefore have to divide 10 by minus 5 as well. So on the left-hand side, we will be left with x. And on the right-hand side, we will take 10 divided by minus 5, and we will get minus 2. And that's our final answer for question 3. For question number 4, we have 4x plus 7 plus 6x equals minus 5x minus 23. Step 1, once again, is to make sure that all of the constants are on the right-hand side. So we can already see that plus 7 is going to have to move. We do that by getting rid of it on the left-hand side. So we say minus 7. And on the right-hand side, we'll have to do the same and say minus 7. So as we can see, the plus 7 and the minus 7 are going to cancel, and we are going to be left with 4x plus 6x on the left-hand side, and this equals minus 5x minus 23 minus 7. And as we know, minus 23 minus 7 should give us minus 30. So step 1 is finished, as we have moved all of our constants to the right-hand side. Our next step is to move all of our variable terms over to the left-hand side. As we can see, we have already got 4x plus 6 on our left-hand side. This can actually be simplified to 10x, as we know that 4 plus 6 is 10. Therefore, 4x plus 6x will give us 10x. We also know that this is a variable term, minus 5x, that is going to be needed to move over to the left-hand side. And to do this, we are going to add 5x to the left-hand side. As remember, since we have a negative over here, we need to add a positive number. So minus 5x plus 5x will both cancel out to give us 0. Right, and whatever we do to the one side, we have to do to the other. So remember, we added 5x to the right-hand side. We will therefore also need to add 5x to the left-hand side. And this equals, now as I said earlier, the minus 5x and the positive 5x will cancel, meaning that we will only be left with negative 30. So we can then add the 10x and the 5x. This will give us 15x, as 10 plus 5 is 15. Therefore, 10x plus 5x will give us 15x. And this equals negative 30, as we are just carrying that over. Lastly, we need to get x alone. And to do this, we need to get rid of this coefficient. And we get rid of this coefficient by dividing the entire term by the coefficient of x. And the coefficient of x is 15. Therefore, we divide 15x by 15. And whatever we do to the one side, we do to the other. So we divide there by 15 as well. So 15x divided by 15 will simply give us x. And negative 30x divided by 15 gives us minus 2. And that is our final answer for question number 4. Question 5. Here we have 10x plus 7 equals 12 minus 2x. So we need to move this constant term over to the right-hand side. And remember, whenever we are moving a term, we are simply changing its sign and moving it over to that side. Now, instead of me subtracting from both sides, as I've been doing previously, a slight shortcut is to simply just get rid of it on this side and to add in the minus 7 over there. It's the exact same principle, it's just slightly less writing out that I need to do. So what we have done here is we have moved this minus 7, rather we have moved this plus 7 to the right hand side, and its sign has just changed from a positive to a negative. So we now have 10x equals 12 minus 2x minus 7. And remember, we can now let the constants interact. So 12 minus 7, and this simply gives us 5. So we can write that in. And now all that is left is for us to move the minus 2x over to the left-hand side. Now, in a similar way to which we moved the positive 7 to the left-hand side, we can move this minus 2x to the left-hand side. And to do that, we get rid of it on the right-hand side, and we put it back, or we put it on the left-hand side. And remember, since we had a minus over here, we are now going to have a plus. So when we move a term from one side to another, we get rid of it on the original side, just like how we move anything, right? That means when we move, let's say, our water bottle from one spot to another, it is no longer in its original spot. We then put it in its new spot. But with these terms, when we move a term from its original spot to another spot, its sign changes, right? When it hops over the equal sign. So just like this positive 7 moved over the equal sign, this negative 2 moves over the equal sign. And as soon as it moves over the equal sign, the sign in front of the term simply changes. If this is too confusing for you guys to understand, don't worry. Just stick to the same approach that we have been taking all along. Now to carry on, we can then say 10x plus 2x, and this gives us 12x, and this equals 5. And now remember, we want to get x alone. So to do that, we are going to divide by the coefficient of x, which is 12. We'll divide 5 by 12 as well, because whatever we do to the one side, we do to the other. And we will be left with x equals 5 over 12. And we are done for question 5. For question 6, we have 6 times, and then in brackets 1 plus x equals minus 14. Now, before we can proceed with the whole moving of constants and variables, we first need to multiply out the brackets. That means we're going to multiply 6 with 1, and then we're going to multiply 6 with x. This will give us 6 when we multiply the 1 with 6, and we then say plus 6x, which is what we get when we multiply the 6 with the x. We then add x, because that is what we had over there, and we say that this equals minus 14. Now that we have multiplied out the brackets, we can continue as per usual. We know that we are going to be moving that 6 over to the right-hand side, so we minus 6 from this side, and we minus 6 from this side. So when we minus 6 from the left-hand side, we see that the two 6's are going to cancel, and on the left-hand side, we are going to be left with 6 plus x. But wait, we can see that both of these terms have x in them, so we can actually add them together. And this is going to be 7x, because remember, 6 plus 1 is 7, therefore 6x plus x will give us 7x. And this equals, now on the right hand side, we will have minus 14 minus 6, and this will give us minus 20. And lastly, we want x by itself, so we divide by its coefficient. So we divide by 7, and we do the same thing to the minus 20. And this means we are left with x equals minus 20 over 7. And that is our final answer for question number 6. For question 7, we have x plus 2 times, in brackets, x plus 4 equals minus 4. Now, once again, before we can continue with step 1 and 2, we need to multiply the 2 into the brackets. So, on the left-hand side, we will have x plus 2 times x is 2x, and 2 times 4 gives us 8. So we plus 8. And this all equals minus 4. Now we can carry on and move all of our constants to the right-hand side. And as we can see, it is just 8, which needs to be moved over to the right-hand side. So to move 8, we simply subtract 8 from the left-hand side, and we'll do the same to the right-hand side. And as we can see, when we take positive 8 and we subtract 8, they will cancel out to give us 0. And on the right-hand side, minus 4 minus 8 will give us minus 12. On the left-hand side, we can see that we have an x plus 2x. Now, because both of these have the same variable, we can add them. And 1 plus 2 is 3, therefore 1x plus 2x gives us 3x. Now, we need to get x by itself. To do that, we are going to divide by the coefficient of x, which is 3. We'll then do the same thing to the right-hand side and divide that by 3. Therefore, when we divide 3x by 3, we will get x, and when we divide minus 12 by 3, we'll be left with minus 4. Therefore, x equals minus 4 is our answer to question number 7. For question 8, we have 3 minus 2 times 4 minus x. This equals 5 times x plus 1 plus 2. Now, once again, we first need to multiply these numbers into the brackets before we can carry on. So, on the left-hand side, we will have 3 minus 8 plus 2x, because minus 2 times minus x will give us a positive, and minus 2 times minus x gives us positive 2x. This equals 5x plus 5, and then we drop the plus 2. Right, so to make things a little bit easier for ourselves, we are now going to simplify both sides. As we can see, on the left-hand side, we have 3 minus 8, and we have 5 plus 2 on the right-hand side. And just to make things a little bit easier for ourselves, we're going to add these constants together. So, when we say 3 minus 8, this is going to give us minus 5, and we keep the plus 2x. This then equals, now we add the 5 to the 2, and that will give us 7, and we keep the 5x. This was a positive 7. Alright, now we need to move all of the constants over to the right-hand side. So we need to move this minus 5 to the right-hand side. Since we are minusing 5 on the right-hand side, since we're minusing 5 on the left-hand side, we need to perform the opposite operation. Since we are minusing, we need to add. And what are we going to add? Well, we simply have a look over here, and because that is a 5, we are going to add 5. So we've added 5 to our left-hand side, and now we need to do the same to our right-hand side. So our minus 5 and our positive 5 will cancel out, and we will be left with 2x on our left-hand side, and on our right-hand side, we will have 5x plus 7 plus 5, and 7 plus 5 is 12. So on our right-hand side, we will have 5x plus 12. Since all the constants have moved over to the right-hand side, we now need to move all of our variable terms to the left-hand side. And as we can see, we have got 5x on the right-hand side. This needs to be moved to the left-hand side. So to do that, we need to firstly get rid of this term. And to do that, we simply subtract it from the right-hand side. And whatever we do to the one side, we have to do to the other. So we subtract 5x from the side as well. Once we've done that, we can simplify. So 2x minus 5x, that becomes minus 3x. Since 2 minus 5 gives us minus 3, 2x minus 5x gives us minus 3x. Now on the right hand side, the 5x and the minus 5x cancel out to become 0, and we are just left with 12. Lastly, we need to get rid of the coefficient in front of our variable, so we divide by the coefficient. So we divide by minus 3. And on the right hand side, we do the exact same thing. This means that on our left hand side, we are going to be left with x, and on our right hand side, we're going to have 12 over minus 3. And we can simplify this. 12 divided by minus 3 equals negative 4. So on our right hand side, we have minus 4. Therefore, x equals minus 4 is our final answer for question number 8. Question 9. Here we have 2x minus 3 times 2 plus 4x. This equals 2 minus x plus 2. And once again, to start off, we are going to need to multiply the numbers into the brackets. So on the left hand side, we are going to have 2x minus 6, and minus 3 times positive 4x is going to give us minus 12x. This equals 2 minus x, and remember there's essentially an invisible 1 in front of the brackets there, so it's essentially minus 1 times x. That's what gave us our minus x, and minus 1 times positive 2, that gives us minus 2. Now we can simplify. If we have a look at our left hand side, we see that we have two terms which have the same variable. We see that we have a 2x and a minus 12x. So we can let these two terms interact. So since 2 minus 12 is minus 10, 2x minus 12x will give us minus 10x. And we keep the minus 6. This equals, now we can do a similar thing over here. Since we've got two constants, we can let them interact. And we've got 2 minus 2, which we all know is 0, so we don't have to write anything. Then we will be left with our minus x, so we can keep that there. Alright, now we need to make sure that we move all of the constants over to the right hand side. And as we can see, we have got negative 6 on the left hand side, which needs to be moved over to the right hand side. So since we have a negative number, we know we need to add. And how much are we going to add? We add 6. This is to make sure that when these two interact, when we add minus 6 to something, we need to make sure that that equals 0. That is why we are adding positive 6. So we add 6 to the right-hand side as well. Now we can simplify. On the left-hand side, we are going to be left with minus 10x. And on the right-hand side, we are going to have minus x plus 6. We now need to move all of our variables to the left-hand side. So because we've got minus x on the right-hand side, we are going to add x to the right-hand side, and we will therefore add x to the left-hand side as well. So we can simplify, and on the right-hand side, negative x and positive x are going to cancel, so we are just going to keep the 6. On the left-hand side, we've got minus 10x plus x, and as we know, minus 10 plus 1 gives us minus 9, therefore minus 10x plus x gives us minus 9x. Lastly, we want x by itself, so we divide by the coefficient. The coefficient of x is minus 9, so we divide the left-hand side by minus 9, and we do the same to the right-hand side. And therefore, we are going to be left with x on our left-hand side, and when we divide 6 by minus 9, we can divide the top and the bottom by 3. So we're going to get 3 over minus 2. And that is our final answer for question number 9. For question 10, we have 2 times x minus 3 minus x minus 2 equals 2x plus 3. So we multiply into the brackets, and we get 2 times x gives us 2x. 2 times minus 3 is minus 6. Then we'll have minus, remember there's an invisible 1 over there, so we have minus x and plus 2. This equals 2x plus 3. Alright, now on the left-hand side, we can begin to simplify. So, because we've got a constant over here and a constant over here, we can let those two interact. And minus 6 plus 2 is minus 4. The same with 2x and minus x, because those two both have the same variable, we can let them add with each other, and 2x minus x is similar to saying 2 minus 1. So when we say 2x minus x, we will just be left with x. Right, so now we can move over to the right-hand side, where we will have 2x plus 3. As we can see, nothing was able to add up on that side. Alright, now we need to add, or rather now we need to move our constants over to the right-hand side. So this is a constant that needs to move over to the right-hand side. We are going to perform the opposite operation to minus. So we plus, and we plus 4. And whatever we do to the one side, we do to the other. So we have to add 4 here as well. So we are going to have x left on the left-hand side, and this will equal 2x. And remember, 3 plus 4, we can add up our constants, and this is plus 7. Now, we need to move our variable terms over to the left-hand side. So because we've got essentially a positive 2x over here, we need to minus 2x from the right-hand side. And we do the same thing to the left-hand side. We also minus 2x there. Alright, now let's have a look at the left-hand side. x minus 2x. If we say 1 minus 2, we get minus 1. Therefore, x minus 2x is going to give us minus 1x. And we don't write the 1 in front of the x. On the right-hand side, we are going to cancel out the minus 2x and the 2x, and that gives us 0. So that means we are left with positive 7. Lastly, we need to get x by itself, so we're going to divide by the coefficient, and as we know, there's always an invisible 1 in front of x when it's by itself, so this becomes, or rather the coefficient of x is minus 1. So we divide by minus 1, and we do the same thing on the right-hand side, divide by minus 1. That means on the left-hand side, we're going to be left with x, and on the right-hand side, we are going to be left with minus 7. This is our final answer for question number 10. Now remember, all we were doing here was we were trying to get x by itself. All of these operations we were doing was to get x alone on the left-hand side and a constant alone on the right-hand side. And this is how we can obtain our value for x. Remember, we are always looking for x when we are solving these equations.